and our project is the freeze concentrated beer.
I'm Carl Littrell.
I'm Courtney McLean.
I'm Margaret Cordy.
So our project, we wanted to concentrate beer similar to what Gatorade or Pepsi or Coke might do in order to reduce transportation costs and also to reduce the environmental impact that the product would have as far as gas usage and things like that go for transporting the product. We looked at ways that involved heat, but the problem is when you heat up beer, you're going to lose a lot of the alcohol content, which a lot of people drink beer for that purpose, and then you're also going to change the flavor undesirably. So then we looked at freeze concentration. Freeze concentration involves bringing the product down to its freezing point, at which point the ice will float to the top and the higher concentration will float to the bottom. So you can separate off the ice, clean it, use that water elsewhere, reuse it, of course being environmentally friendly, and then your higher concentrated product will later come out the bottom kind of like a syrup that you can package and ship off. And so we ran a few kitchen experiments. It was difficult to really get a product that we could use because we didn't have the right equipment necessary. This is a very large-scale process, but we were able to see that indeed after freezing it and thawing and freezing, we do kind of make a syrup that is a higher concentration that would be able to be packaged, shipped off, and then once it reaches its destination, you could add water back up and you'd have a full beer product again.
What were some of the design constraints or quality issues that you had to try to achieve to have a successful product?
Carl talked about the fact that if we applied heat to the beer, then we'd be affecting the flavor, we'd be affecting just all over just the beer. So we wanted to stay away from heat specifically. That's why we chose freeze concentration. We also looked at 5 or 6 different ways that we could concentrate the beer, from boiling it on the stove to freeze drying to freeze concentration, and we finally decided that freeze concentration would be the best thing for us.
Wait, all right, I'm ready.
Okay, so to further optimize our process, as Carl talked about right here, we identified kind of 3 problematic areas and ways that we can further improve it. For example, you can see here, one problem that could occur would be foaming in the feed tank. So in order to optimize that, we suggested adding a floating cap to that tank, and that would minimize that foam buildup that you would have in that tank. And then also, we want to utilize all the heat that we have in our process, because if you look at our diagram, you'll see we have a heating unit that is being used to kind of melt the ice and reintroduce it back into the system. So what we thought would be a great idea was to use the heat that's coming off that heat exchanger, because it's cooling the product by removing the heat, and just use that to heat that heating unit so that we'd be more energy efficient in that means. And then also you can see that we have wastewater coming out of that. So again, that's not really optimal. So what we thought would be another great idea would be to utilize that wastewater, potentially introduce it back into the brewing process for like malting or what have you, or just use it for CIP purposes for cleaning.
What we did in the lab was put our product into a freezer. We used 2 different types of materials for the containers in which to freeze the beer. One was applesauce cups, like little plastic cups you get an applesauce in, and the other one were silicone cups. They use them for baking. They're like little muffin cups. And we took the temperature over time as the beer froze. And you can see here, this is where the product is still liquid, and at this point, that's your initial freezing point. You start freezing the water in the beer, and as you freeze, you get more and more concentrated, and then down here we ran into some temperature cycling within the freezer.